Okay, I'm Rene from Germany. I'm running a little Wi-Fi design studio for my living, and sometimes I'm developing some weird hobbies. Yeah, thanks for voting for this time slot. I was a little bit surprised, maybe because of the title, I don't know. That's why I want to start with a disclaimer. Yeah, because I think it's important. So, yeah, that's it. And of course, I will talk about a new German angst. So the new German angst, by the way, is even an angst by myself. So is the antenna pattern or the antenna model, which I want to use for my design, based on a model, on a simulation and stuff, will this be correct? So that's a big angst, and I started to think if we should verify antenna patterns. And I would say yes, because, you see it, a lot of things can happen on the way between the definition done by the OEM, going to the company who is doing the design software, and between these, a lot of things can happen. Failures, misinterpretations, things and stuff. So I have seen several samples on that, and I think everybody has some own stories about that. So yeah, how can we try to verify antenna patterns without having an chamber, an anechoic chamber ready, without having this 5-digit high investment in measurement equipment? So, and I asked myself why I could try to use the Sidekick to add an additional task on the Sidekick tasks to solve. Everybody knows what you do with that device. Yeah, I asked myself if I could try to use this device for antenna measurement. Yeah, to start with this, I like to do some analysis of the free space loss, because I wanted to find out in what range I would place the antenna-AP from the measurement device. And that was the first question. And the second one was how to avoid too much energy going around based on multipass effects. So I looked for a low value of the transmission power, or better talk about the IRP, the power which comes from the antenna. So, and yeah, I decided to go within the short distance, within 1 meter. So I just created a measurement based on a 1 meter distance between the measurement device and the access point in this case. And I configured the AP to a quite low 5 dBm EAP. Yeah, so, and very hasty, I created the setup and spent a sunny afternoon on the balcony. Yeah, what I used to measure the angle, yeah, you may see it, and I have it with me, this one. One I had to destroy because of the tripod. Of course, the original device I also have here, so if one wants to see, very easy. So that means the measurement was, I'm taking the angel, measured the SSI, changed it 30 degrees, not 5 degrees or 10 or 15, because it costs a lot of time to put together all the measurement points. So after taking the measurement, I just put it on this kind of hasty developed diagram. I used absolute values for the RSSI. So because I calculated based on the AIRP the distance I could reach, the range I could reach in absolute values of RSSI. So, and this is one of the results. I took another one just to see if it works in addition, and yeah, I have to do a live animation because I was not able to automatic. Yeah, so, and this was the result. I started with the vertical because I hope the vertical will show something. So, and let's see how it looks like. So you see the original manufacturer diagram. You see a diagram from a software, you know. And yeah, if you wish, you can see that it isn't a circle. Yeah. So, but I was satisfied because I didn't expect to find out what is the real gain of the antenna, because for that you have to do something more. And I was satisfied because the shape fits a little. So more exciting I was to do the same with the horizontal. And yeah, here the same, the result, and the original manufacturer diagram. So that's it. I'm developed the things a little bit and try to create a procedure to collect the measurement points based on saved data. So I used the Ekahau feature set there, and now I'm waiting for a bright moment to get all these points in a table together with the angel. Yeah, but I'm not ready with that. So that's I want to show, and I'm in time, I think. So.